Welcome to the Math Record. Today I'll be covering the second part of the ICTM Regional 2019 Division AA Freshman Sophomore 8-person, which I'll be answering questions 17 and 19, while part 1 answered question 8 and question 11. Okay, so let's start with 17. So we have this diagram, and let's just kind of draw this first. So we have a circle, we have another circle. Okay, that looks fine. Then basically we need to draw our centers. And now we just need to put our lengths all in. So we have a line that's straight down. We have this line straight down and a line that connects the two centers. And then we have some kind of internal tangent. Some line that connects it from here. A line here. And then we have a line here and a line here. Cool. Okay, so basically what we had to do is we just need to find some lengths. So we know PO is 2. And we know QR is 8, so those are radius, so that tells us this is 2 and this is 8. And now let's first get our common external tangent. So if you know how to do this, I have a video also in my channel in my what is this class, which I just teach how to get the common internal or external tangents. So all we had to do is just add the lengths to get the distance between the two circles, which is 10, and then square it minus the distance between the radius, which is 8 minus 2, which is 6. So 6 squared, take the square root, and that's our common external. So 10 squared minus 6 squared, that's just 8 squared. So square root of that, that's 8. So we know this distance down here is 8 because that's our common external. So what we need to notice is that from this point to, let's change color, to this point of tangency, to this point of tangency, and to this point of tangency, all of these are the same lines because it's gonna be this is equal to this and this is equal to this, so that's both x. And for this circle, this is also equal to this. So that gives us that these three lengths are equal in length. So since both of these two x's make the 8, that means both of them are length 4. So okay, so length 4, length 4. And now we know this is 90 degrees, so then we could just get the hypotenuse. So 2 squared plus 4 squared. So 2 squared is 4, 4 squared is 16. Add them together, that's 20. Square root that, that's 2 square root 2. So this entire length is 2 square root 5, I mean. Okay, so now we could just we need to get the height right here. So then basically, all we have to do is just think about the area. So 2 times 4 divided by 2 gets the area of this triangle, which is also this base, which is 2 square root 5, times the height divided by 2. So that gives us that 2 times 4 divided by 2 square root 5 is equal to h, which is equal to 4 square root 5 over 5. Okay, so we know that this height now is 4 square root 5 over 5. And um, and we know from geometry that basically if we have a chord inside of a circle and we have a line that cuts it like from the center and it cuts it right down, it's gonna be bisecting it. So that tells us that this length is equal to this length. So this is also 4 square root 5 over 5. And now we just need to get this length. Well, we already know this triangle, so we could just do that. So that gives us that this side length squared plus 4 square root 5 over 5 squared equals 4 squared. So that is just 16 minus 16 over 5. So that gives us that 4 times 16 over 5. And then we take the square root of that, which is just 8 square root 5 over 5. Okay, so 8 square root 5 over 5. So we got this length and this length. Now we just need these two lengths. Well, if you kind of think about it, we don't really need to find them because we already found them. And the reason is because this is a 90 degrees, right? And we know that this these two lines make lines of tangency, and if you think about it logically, that tells us that this line is also this angle is also 90 degrees. So, which you could also prove, but it's definitely going to be 90 degrees. And if this is 90 degrees, and this is 90 degrees, and this is 90 degrees, right? Because technically there's the same thing opposite of each other. So then so that tells us that this is a rectangle. So this is 4 squared 5. This is also 4. This is 4 squared 5 over 5. This is also 4 squared 5 over 5. This is 8 squared 5 over 5. And this length is also 8 squared 5 over 5. So to get the perimeter, you just need to add these two lengths and then multiply by 2. So 8 times 4 is 12 squared 5 over 5. Then multiply by 2 to get our perimeter, which is 24 squared 5 over 5. And that is our answer for number 17. Okay. Now let's go to question 19. So we have a graph n squared minus x squared where n equals the product of p and q of which is distinct prime numbers less than 10. And they have these three intercepts. K is the largest and W is the smallest area. Find the number of positive integral divisors. So let's kind of draw a graph. So I know it's a quadratic concave down based on that general formula. So that gives us our three intercepts are these. And if our n is p times q, that means our x-intercepts are negative pq, right? It's going to be negative pq 0, and this is positive pq 0. And then the y-intercept would, when you plug in x equals 0, so then that's just p times q. So that's 0 p 0 pq squared. Okay, so this is our coordinates. So to get the area of this, all we have to think about is when we connect our triangle, it's just base times height times 1/2, right? So our base is negative pq to pq, which is 2pq, times our height, which is just pq squared, and then divide by 2 to get our area. So that gives us that our area is equal to pq cubed. Okay, so we know that is true. So let's just work with this. So area equals P times Q cubed. So we know that P and Q are prime integers less than 10. So the prime integers less than 10 are 2, 3, 5, and 7. So that means the smallest area is 2 times 3 to the power of 3. So that is equal to our W. And our largest of K is equal to the product of the two biggest numbers, which is 5 and 7 to the power of 3. And now we multiply them together. That is 2 to the power of 3 times 3 to the power of 3 times 5 to the power of 3 and 7 to the power of 3. So that is K times W. And now we need to find the positive positive integral divisors. And an easy way to do this is add 1 to each of the exponents. So that's 4, 4, 4, and 4. And then you multiply them all together. So 4 times 4 times 4 times 4 is equal to 256. And that's your answer for number 19. Well, that basically covers 17 and 19 and completes this year's freshman sophomore 8%. Thanks for watching, and I'll see you at the next math record.